This video has sound, so hopefully everybody can hear my voice. If not, they're watching me point to this sign and hopefully trying to get your sound up and running. This lesson is in the Chapter 4 Study Guide for Geometry, and it is on Section 451. This is Chapter 4, Section 5, Part 1. And I'm also going to do Chapter 4, Section 5, Part 2. This was a typo. This was supposed to be a 2 here. So far in this chapter we've been using triangle congruence as an overall concept, and the way that we first learned that two triangles could be demonstrated to be congruent is that if we could establish 3 pairs of angles that were congruent and 3 pairs of sides that were congruent, then we could conclude that the two triangles were congruent to each other. Then we started learning these things called shortcut theorems. That's at least what I like to call them. The first shortcut theorem was the side-side-side congruence postulate, and it said, hey, you don't actually have to establish all 6 parts, all 3 angles and all 3 sides. This one says that if you just stick to the sides, if you find 1, 2, 3 pairs of corresponding sides and prove that they're congruent, then you can go ahead and skip ahead and say, yeah, these two triangles are congruent. Or another shortcut theorem, rather than doing all 3 sides and all 3 angles, you could do just a side angle side congruence, meaning that if you had a pair of sides, a pair of angles, and a pair of sides where the angle pair was in between the 2 side pairs, then you could jump ahead and say that those 2 triangles were congruent without having to establish all 6 parts, all 6 pairs of things congruent. The next shortcut theorem had to do with only right triangles, and that was called hypotenuse leg. If you could show that the 2 hypotenuse were congruent, and then any pair of legs, either this pair or the other pair, whichever, on a right triangle were congruent, then you could say that the 2 triangles were congruent. So you could see here, hypotenuse leg pair, so these 2 are congruent, or hypotenuse leg on this one, and so on. So Section 451 and 452 are on the last 2 types of shortcut theorems. The first one is called angle side angle, and it is here's an example of the theorem. The angle side angle theorem says that if you have an angle that's congruent to its corresponding angle over here, and a side that's congruent to a corresponding side over here, and then another angle that's congruent to a corresponding angle over here, if you can establish 2 angles and the side in between on one triangle to be congruent to 2 angles and the side in between that corresponds over here, then you can say that those 2 triangles are congruent by angle side angle. Congruence postulate. So we can create a proof down here using that. So they want us to use the angle side angle congruence postulate, and let's see what we've got here. Well, I've got side ZY marked congruent with side XW, so I have 1 pair of sides, and it says that in the given here. And then that's pretty much it. They haven't given me any other side angle pairs or side pairs or angle pairs. So let's see. You see this double angle or double arrow here with this double angle there? That means that side VY is parallel to side UW. And if this line, if you think about this as a transversal, so this is your line and the other line that it's parallel to, and then this is your transversal, then if you think about it, this angle and that angle would be corresponding angles, and corresponding angles are congruent when the 2 lines are parallel and the transversal runs through, right? So I would want to establish angle ZYV congruent to angle XWU. And then that would give me a pair of angles on each triangle that are congruent. So I've got a pair of angles and I've got a pair of sides. Now I need another pair of angles. So I can use the same concept. I have a parallel line here with this one. And then if this is still my transversal, I would have a pair of corresponding angles here and here. And so if you have a pair of parallel lines and a transversal that cuts through, the positions of angles that are corresponding must be congruent. So I have angle YZV, that's this one. I want to prove that that's congruent to angle WXU. And that would be my other pair of angles that are congruent, right? So on one triangle, I have an angle side angle. Remember, the side has to be in the middle between the two angles. And on the other triangle, I have an angle side angle where the side is in between the two angles. And all of those pairs are corresponding. If I can prove that set is congruent to that set as they go across and match up, then I can say that I've proved the two triangles to be congruent. So I'm going to start with my given information. Those two pairs of lines are parallel to each other, and this line segment is congruent to that line segment. I used, the reason for these two is the same as the corresponding angles postulate. So I have angle ZYV congruent to angle XWU and angle YZV congruent to angle WXU. And corresponding angles postulate is the reason for both. So I have pair of angles, pair of angles, pair of sides that are congruent. So I can go ahead and state that WXU as a triangle is congruent to YZV as a triangle, according to the angle side angle congruence postulate. Okay, and now we're moving on to 4.5.2, that's chapter 4, section 5, part 2. Again, this was a typo right there, so change that 1 to a 2. Alright, on this page we're going to practice the last shortcut theorem called angle side. Angle side says that if you have a pair of corresponding angles, and then another pair of corresponding angles, and then a side that is not in between the two of them, it could be over here or over here. If you can establish angle side or side angle, it doesn't matter. As long as the side is not in between the two angles, then you've demonstrated two triangles are congruent. So here's an example of how we could apply that and write a proof using angle side congruence theorem. Alright, so it says that BE is congruent to BC and angle A is congruent to angle D. So we have a pair of angles and a pair of sides. Okay. So if we could establish one more pair of angles then we would should potentially be able to use our angle-angle side congruence theorem to prove these two triangles are congruent. And that's the theorem they want us to use here. Well, the only other pair of angles that I can see are clearly congruent would be this angle right here and this angle right here, right? These are two intersecting lines at point B, and these two angles are angles that are across from each other on that intersection. And those two would have to be congruent based on the vertical angles congruence theorem. So angle ABE would have to be congruent to angle DBC. That's really all we would need, because then we would have an angle here corresponding and congruent to an angle over there. So in this triangle we would have angle-angle side, also known as side-angle-angle, doesn't matter. And on this triangle we would have angle-angle side, or side-angle-angle. As long as the side is not in between the two angles, it's the same theorem. So, getting our proof written formally, I would start with my given pieces of information. BE is congruent to BC, and angle A is congruent to angle D. Secondly, I wanted to establish that these two angles were congruent, so I want to say angle ABE is congruent to angle DBC because of the vertical angles congruence theorem. And then I would have my angle-angle side pairs. So I could say that triangle ABE is indeed congruent to triangle DBC by the angle-angle side congruence theorem. Okay, so over here, they want us to figure out what the missing part is. So if DE is congruent to MN, and M and D are congruent, then for side angle side, what would we have to do? Well, I'm thinking I need a pencil for this. So let me see if I can get myself a pencil. Okay. Well, I have a pencil, kind of. I guess it'll have to do. Alright, so if DE is congruent to MN, that's this side and this side, and then M and D are this angle and this angle. If we want to use side angle side, so we have side angle, remember the angle would have to be in between the two pairs of sides that are congruent, so I would say that this side and this side would be next to this angle, so this would be the side I would want to use for side angle side, like so. So the last thing I'd want to do to establish a side angle side congruence would be to state that DF is congruent to MO, and then I would have my side angle side. Well, I don't have a functional eraser, So, let's see what I can do. Yeah, that's not working. All right, let's try this then. Okay, so fresh diagram for number 2. This was D. Okay, so on this one they say that FE is congruent to ON and F is congruent to O. Now, if we want to use the angle-side congruence theorem, remember the side cannot be in between the two angles, it has to be around the corner from them. So if I wanted to have angle-side, if I chose these two as my angles, then you see how the side would be in between the two angles? So that wouldn't work. So it must be this angle down here, these two pairs of angles, that would give me angle-side. So I would say that my answer for this one is angles D and M. I would want to prove them congruent. Okay. And then finally, if DF and MO are two sides that are congruent, and angle F and angle O are congruent, then by angle-side angle, how could we show these two triangles are congruent? Well, an angle-side angle, the side has to be in between the two angles. So if this was the side, it's between angles M and O. So I would want to establish that angle M and O are in between side S. And angle D and F are in between side S on this side, side DE, or DF and MO, whatever. Okay, so basically these two angles, D and M, are the ones that I would want to establish are congruent in order to use angle-side angle, in order to create a side congruent pair in between two angle congruent pairs. So again, it's angle D and angle M that I would go for with this one. All right, and I made a big mess of my paper, but that's okay. I'm rolling on the whiteouts and rolling it off at the same time. There we go. Close enough. Okay. On the next one, we can use the same ideas. We have angle A is congruent to angle X. We have angle B is congruent to angle Y. And how would we establish angle-side? Well, on this one, the side cannot be in between the two angles. It has to be next to them. So it can't be this side. So we could choose side AC and XZ, or we could choose side BC and YZ. We have actually those two possible options to have angle-side. I'm going to go with the first one. Side AC could be proven congruent to side XZ for angle-side. Or you could also go, instead of this, you could say BC is congruent to YZ. That would also work. As long as the side's not in between the two angles, you're good to go. Okay, on this one they have angle A and angle X congruent, and then they have a side congruence of side AB and XY. So if we're trying to use the angle side angle, where the side is in between the two angles, here's the side, here's an angle, so it'd be angle side angle, the two angles on each side of this side. So we would have to establish that angle B was congruent to angle Y over here in order for the side to be in between the two angles as you go around the side of the triangle. Okay. All right, and then the last one here, number 6. If BC is congruent to YZ and angles C and Y are congruent, so I have this pair of sides here and here, and this pair of angles here and here, how would I establish these two triangles are congruent if I had to use the angle-angle side congruence theorem? Remember, the side cannot be in between the two angles, so it couldn't be angles B and Y that I would want to show are congruent, because then that would be angle side angle and the side would be in between. In this theorem we want the side to be not in between the two angles. So the other pair of angles that we would have to choose are not these two, but it would have to be up here. It would have to be angle A and angle X, right? Because then that would be either side angle angle or angle angle side, the side not being in between the two angles. That's the only arrangement where that would work, where that would exist. So angle A and angle X are my choice there. Okay. Now the last few examples simply asks if it's possible to prove that the two triangles are congruent. Now this is tricky because we have a lot of different theorems to prove to choose from. We have side side side, we have side angle side, we have angle side angle, we have angle angle side, we have hypotenuse leg. So that's basically 5 different choices. So we'll have to think about if any of those 5 shortcut theorems can apply to the diagram we're looking at. Well, I see a pair of sides that matches here because WL will be congruent with itself. I see a pair of sides that matches here and here, and I see an angle matching with an angle. So in the bottom triangle, I have 2 sides and then an angle that's not in between. Same thing for the top triangle. I have 2 sides and an angle that's not in between. It turns out there is no such theorem. There is no shortcut method for establishing 2 triangles to be congruent when you have 2 sides and an angle not in between. You can have 2 angles and a side in between, but you cannot have 2 sides and an angle not in between. So this would be no theorem exists. So these would be not proven to be congruent based on what they gave us. In example 8, I have a pair of angles here and here that are congruent. I have a side here and here. This pair is congruent. And then, well, there'd be no way to prove any more sides are congruent without maybe a midpoint or some parallel nature of the structure of this diagram. The only other thing that we could be able to prove congruent would be that this angle matches this angle, because that's a vertical pair of angles. So I've got angle, angle. So on the top, I have 2 angles and a side not in between. Same thing on the bottom, 2 angles and a side not in between. And that is the angle-angle side congruence theorem, right? So by the angle-angle side congruence theorem, these are congruent triangles. And then finally this pair of triangles, I have angle H and angle L that are congruent. I have an angle pair. I have side S, or side KH and side GL. Those 2 sides are congruent. And then this angle right here is a right angle, and so is this one, so I have another angle pair here. I don't see any other sides or that could be established as congruent. So let's see, I have two angles and a side that's not in between for each triangle. Two angles and a side, two angles and a side not in between. Yep, same theorem as that one. Angle, angle, side. Will do the job for us there.